Are there diamonds on Mercury? The new image from the James Webb Telescope changed everything we thought we knew. It showed us that a simple planet like Mercury can be full of mysteries, like holes filled with diamonds. Right next to the Sun, this great discovery will hit our screens and show our devices right away. What other secrets does Mercury hide? Let's dig deeper into these secrets. Deep space exploration. The first look at Mercury's orbit is fascinating. When it appeared on the screen, it was what we expected to see. At that moment, we knew we had hit it hard, and everything was going to be okay. NASA has just revealed an amazing space discovery, right on a small planet. Despite its simple appearance and proximity to the Sun, it holds secrets and mysteries beneath the surface, including holes that may contain diamonds. But as we zoomed in, the room fell silent. There, in the shadow off the crater, is an artificial structure, a hidden Mercury will never hold. This tiny planet that once seemed like a tiny speck in our telescopes has become a marvel. Thanks to the advanced technology of the James Webb Telescope and other missions, we are beginning to make some amazing discoveries. Recent studies show that diamonds exist in the volcanic environment. But that's not all. The extreme is unusual, forcing scientists to rethink what they know about the formation of planets. We haven't known much about Earth for years, but new technologies are slowly starting to reveal its secrets. NASA's Mariner 10 mission in 1973 was a major step in planetary exploration, and Messenger followed in 2004. While Messenger was in orbit, it captured detailed images of a surface covered with craters and strange ridges, similar to the surface of the Moon. The images reveal a dense, porous planet with a surprising magnetic field and a core larger than expected, prompting scientists to rethink their understanding of the universe. 31 years after the Mariner 10 mission, the Messenger probe, designed to go into orbit, has a clearer view of the world. It stayed in orbit and collected a large amount of data, more than 200,000 images, showing areas that have never been seen before. Among the most interesting findings is the abundance of calcium and magnesium in dark areas. The discovery made scientists wonder how these elements ended up there, not on Earth. Magnetic fields are created by the movement of liquid iron in the core, but the unique structure of the interior creates different types of magnetism. During the day, the temperature rises to 800 degrees Fahrenheit, hot enough to melt lead. At night, it drops to 300 degrees Fahrenheit. This difference in temperature occurs because thin air cannot hold heat. Despite these extreme conditions, recent studies have revealed some surprising properties of the surface. In 2012, data from the Messenger mission revealed volcanic activity, including signs of explosive eruptions, challenging the long-held belief that the planet was dead. Scientists say they have found water ice in some polar craters. These craters are so cold that the ice remains solid, even though the planet is close to the Sun. The discovery raises interesting questions, such as whether simple life forms can exist on this planet. Despite its harsh environment, is it possible to live there? It may seem unlikely, but some forms of life on Earth can survive under the most extreme conditions imaginable. So, it's not out of the realm of possibility that something could live there, even in cold and very icy places. Currently, a mission called Bepi Colombo, launched in 2018 by the European Space Agency and the Japan Aerospace Exploration Agency, is on its way to the world. The spacecraft is expected to reach 2250 and take a closer look at the surface, its chemical composition, and the history of the Earth. But this planet continues to amaze scientists. For example, there is a magnetic field including water ice, which is not expected from a planet near the Sun. The most unusual thing is how time works there. Unlike Earth, which has bright suns and years, the rotation and orbit create a very different pattern. Did you know, for example, that a year is shorter than a day? Let's see how the unique day and age of this world makes it such a wonderful place. Spin, orbit, and mysteries change generally. The planets rotate on their axis once a day and revolve around the Sun once a year. However, breaks these common rules. The Earth takes only 88 days to make one revolution around the Sun, making a year very short. At the same time, the Earth takes 176 days for a complete revolution. Therefore, the Sun is twice as long in a year. If you stand on the screen, this alternate time pattern leads to strange objects. Imagine the Sun rising in the sky, stopping, backing up a bit, and continuing. This happens because the slow rotation often cannot match. However, due to Mercury's fast and slow rotation, the surface looks very different. For example, there are places called hot poles where the sun freezes in the sky, creating the hottest places on Earth, and the cold, dark regions near the Earth's poles, where the sun never reaches them. Scientists have discovered water ice. It's surprising to see ice on a planet so close to the sun, but it exists because of the difference in rotation. Some pits near the pole are still in the shade and very cold. These ice caves are different from other parts of the world in terms of extreme heat. The discovery of the ice led researchers to wonder if other substances, such as organic compounds, might be hidden in these icy places. But studying in this world is not easy because the day changes quickly. This fast orbit, with extremely long days, poses a major challenge for space missions. The Bepi-Colombo mission, which began its journey in 2018, is going global. He uses the energy of Venus and Mercury to set his course. He is expected to reach his destination in 25 hours after 9 departures. But the mission had to contend with the world's biggest day-night cycle. The spacecraft is exposed to extreme heat during the day, and energy must be maintained during the long, cold nights. These superpowers push the limits of current technology and make it difficult to explore a planet like Mercury. So know why the planet is turning so fast and what it tells about history. Preparing for a hidden threat, recent studies have determined how fast the world is changing. The sun appears to rotate very fast, but it is slowed down by the sun's force and by collisions with larger objects such as asteroids. This gives scientists new clues about the universe's past and helps us understand how the planets of the solar system have changed over time. Scientists are also fascinated by the Earth's massive iron core, which makes up 85% of its volume. It is much larger than the Earth's core, which is only 15%. Some experts, such as Dr. Nancy Chabot of the Johns Hopkins Applied Physics Laboratory and Dr. Eric Asfag of the University of Arizona, believes there is a larger planet than before. They believe that most of its outer layers were lost after a massive collision early in the solar system's history. But this is not an unexpected discovery. The planet also has a magnetic field. Even though it is a small planet, it rotates slowly. Its magnetic field is only 1% as strong as Earth's, a surprising discovery from NASA's Messenger mission. The discovery challenges what we thought we knew about the magnetic fields of dwarf planets. Dr. Katherine Johnson, a planetary scientist at the University of British Columbia, and her team continue to study the case to learn more about the planet's unique features. These findings are forcing scientists to rethink their theories about the formation and growth of planets. The more we learn about the planet, the more we can challenge what we thought about the solar system. This planet has an unusual magnetic field. It is not at the center, but is compressed by 1/5 of the radius of the planet. This unusual phenomenon may be due to the uneven thickness of the surrounding crust, which causes heat to flow differently into the atmosphere. In the 20s, scientists discovered elements such as sulfur, potassium, and sodium on the surface. Normally, these elements would disappear quickly under extreme heat. It is surprising to find them on a planet so close to the Sun. Dr. Patrick Peplowski believes that these elements may have come from comets or asteroids that hit the planet after its formation. Another amazing thing is the water ice in the craters near the poles of the planet. These places are shady and cool enough to keep the ice from melting. Dr. Nancy Chabot was instrumental in this discovery. Those pits also contain organic compounds, which are carbon molecules. These may be the same as those who started life on Earth. This means that the universe holds clues to the beginning of life in our solar system. But that's not all. For a long time, scientists believed that the planet was dead. However, the Messenger mission found signs of a current volcano. They found some areas on surface that may be volcanic. This means that this planet is still a powerful planet. The South Pole of the world is also a mystery. It is a wild and rolling country with hills and valleys the size of Texas. Dr. Thomas Waters believes that the powerful earthquakes caused by planetary cycles caused by the sun's influence created this alien world. Dr. Amir Khan studied data from the Messenger probe and found a liquid outer world with a solid inner layer larger than Earth. This unique structure explains the variable magnetic field. These findings challenge what we think about the formation and evolution of planets, and show that there is still much to learn about our solar system. Now let's dive deep into the universe and onto the surface to see what secrets they uncover. secrets beneath Mercury's surface. This planet is 1,260 miles across, half the size of its parent. Some craters, hidden from direct sunlight, are in ice or from comets or asteroids that have hit the planet in recent millennia. These pits may contain dark matter, possibly organic compounds, such inclusions. The presence of these materials provides a unique opportunity to learn more about the distribution of organic compounds throughout the solar system. The level speaks for its long and complicated history and shows some important differences from Earth, such as the absence of plate tectonics. Even without plate tectonics, it shrinks as it cools, creating many cracks and surface faults. These unique features help us learn more about the planet's fascinating and complex nature. Where one land thrusts against another, the Great Rifts reveal deeper layers and show more signs of contact with previous places. On the 29th, scientists made an interesting discovery. It is still reversible. They found small, narrow valleys called grabens next to large traps. Grabens form as the Earth stretches, and the way they look today shows that the surface is constantly changing and growing. Another unusual feature is its magnetic field, which is different from Earth's. While Earth's magnetic field is created by the movement of molten iron in its outer core, its magnetic field might come from a different source, possibly a layer of liquid metal around a solid core, acting like a dynamo. There is also talk about cracks and gaps beneath the crust that might allow heat, and possibly even liquids, to move through. Although the surface seems lifeless, some scientists think there could be pockets of water deep below, kept from freezing by the remaining heat. This idea isn't as wild as it sounds, considering similar situations on other harsh celestial bodies like Europa, a moon of Jupiter, and Enceladus, a moon of Saturn, which both have oceans beneath their icy surfaces. So the power of water under the dry surface is not out of the question. Exploring the concept, looking into these hidden spaces, piques our curiosity and deepens our understanding of the organizations that create them. Here's something to think about. This knowledge could help us learn about agriculture on other planets and moons as well. It becomes an important piece of a bigger puzzle, helping us learn more about our solar system and how it changes over time. But remember, the story doesn't end here. We are always in awe, and the more we learn, the closer we come to understanding the mysteries of our world. How has time changed? What strange objects are hidden below the surface? And what do they reveal about the early days of the solar system and the shape of the planets? These are important questions and show why we should continue to learn. Every time we learn something new about what's under the surface, not only does it tell us more about the planet itself, but it also helps us understand how all the planets are formed, our solar system over time, and how will it change. When scientists think about the future of space travel, they are excited about what they will find. It may be small and close to the sun, but it still has many secrets to uncover. These secrets can tell more about what's inside. By studying this information, we can learn a lot, not only about this planet, but about other planets in our world and beyond. It can help us understand how planets survive in the harsh conditions near stars and how they persist for billions of years. As scientists continue to release surveys and collect data, each new piece of information can change what we know about space. Because of its extreme heat and proximity to the sun, this is a unique place to test our ideas about the nature and evolution of planets. The more we learn, the more questions we have, the more we become curious and beg to explore things and other planets. Although he is one of our closest friends in space, we are not sure about it yet. We still have questions about the screen, its core, and the nature of what it does. Scientists believe that by studying it in detail, we will learn not only about its history, but also about the early days of other planets, including Earth. Each new discovery can provide clues about the birth and growth of planets in our solar system and other star systems. The harsh environment, the extreme heat, cold and thin atmosphere, is a perfect place to test our theories about the formation and life of planets. Scientists want to know how this small planet could stay so close to the sun for billions of years without breaking up. Are there special properties in it to help him withstand these conditions? Could these materials be found on other planets and other solar systems? Each new mission can change our understanding of the world. Studies with spacecraft help us learn about the surface, its atmosphere, and its contents. As we develop new tools and technologies, we will be better able to see. Each new mission can bring us closer to solving the mysteries of this unique planet and help us understand more about the world we live in. Could Mercury hold the key to finding life elsewhere in the universe? Like, comment, and subscribe for more.